Hello and welcome back to Let's Code Physics. Today we are going to wrap up our potential integrator series. We are also going to wrap up season 3 of Let's Code Physics. This is the next to last video that we'll post for season 3. Tomorrow I'll have up a brief season sign-off video to give you a preview of what we'll be doing in season 4. But this video is scheduled to go up on December 14th, which I think is a good chance to take a few weeks break for the holidays and for me to get some things ready for season 4. So we will be back on in January. But also, since it's mid-December, I thought this would be a fun time to do a little holiday special. So you might recall last time for our potential integrator, we made this code that could make various shapes for us to take the electric potential of. So we can make any shape we want now, or not any shape, but just about any shape we want, so that shape is charged, and then be able to view the electric potential created by that charged shape. The way we're doing this is with a few subroutines like make rectangle that makes a charged rectangle. We can make an arbitrary polygon as long as we have the vertices of it, the x points and the y points that make its corners. We've got a make circle command, and we've even got a make ellipse command. And so what I thought would be fun to do today would be to try out a few holiday related shapes to basically put charges on those and then see what their electric potential looks like. And so the first one we're going to do is a Christmas tree. This one requires several x points and y points. So if you take a look at the pair, we go out along the x and then back in, and then out along the x and then back in, and then out along the x and then back in. So we're making that sort of sawtooth shape. And then we do the same thing over on the other side to get the negatives. So if I run this thing, I think I had this last time where it shows you the shape that we're integrating over. So this is not the electric potential yet. This is just the charged surface. So here is our Christmas tree for you. If you think this Christmas tree is not tall enough, if you would like to see it have more boughs, or if you would like to see it be more of a pencil tree than a wide tree like this, feel free to download all these codes from the description below. Take a screenshot of the results you get and post it in a comment below. So now that we have these points to integrate, we can feed those into our potential integrator here. We are going to, let's not do an angular charge distribution. Let's just do a uniform charge distribution for our Christmas tree. Our Christmas tree is going, let's see, in the range of, looks like 0 to 1, and 1 down to just about -1. So let's, so this range ought to be fine, this -3 to 3. And let's make this 100 points along each axis. And we will run the code and see it march along in the Y direction here. So I'll cut here and see when our Christmas tree, our charged Christmas tree, is done getting its electric potential. Alright, we are coming up on the final corner of our electric potential. Alright, so let's double check the shape here. There in the middle is our Christmas tree. So you imagine you've placed charges on your Christmas tree. I don't know why you'd want to do that. Maybe you rub all the needles with a cloth or something so that you give them excess charge. But here's what the potential looks like. So we've got some pretty sharp pieces around these corners here, not quite so sharp in these areas here. So this is what a Christmas tree looks like from an electrostatic perspective. So that's kind of fun. It would be really neat as if you kind of cast this into a mold, made it into an ornament, and you could have a charged Christmas tree hanging from your non-charged Christmas tree. So that's pretty fun. Let's see. What else do we want to look at? So without stars. Oops, I'll get to that one later. Christmas trees are incomplete without stars. So if we wanted to put a star on top, we would need to create a star. So this is the same header code at the beginning. We're going to use the make polygon for creating our stars here. We'll start out with a 5-pointed star. This one took quite a bit to create, having to figure out all the angles and everything. Star shapes are not entirely trivial to create, but basically we go, so each point is represented by one of these, each outer point of the star is represented by these points that are not multiplied by anything, and then the points multiplied by 0.5 are representing the inner points of the star, or where the star folds back in. So here we get our 5-pointed star here. So we've got a charged star. Sounds like a Pokemon name, charged star. Let's see what this charged star looks like. Let's keep our charge density uniform at first, and then I want to change it up to the angular charge density, because that actually produces some pretty neat results. Alright, here we are coming up on the end, and here is our 5-pointed star. Is this an electric potential? No, this is Patrick. So this looks pretty neat. And the neat thing is that it's so symmetric. If you get a fine enough mesh, you can really see the symmetry of this thing as you rotate it around. So here is our star that we could put on top of our tree if we wanted to, with its own electric potential. I also want to, before we move on to our last shape, I want to use the angular distribution that we had. I think we tried this out last time, where the charge density is proportional to the angle around the shape. And since this thing has a rotational symmetry about it, this actually ends up looking pretty neat. We'll see that in just a minute. So here we've got our 5-sided star with a radial charge distribution, or angular charge distribution, excuse me. And so what we've got here is positive charge on one end, negative charge on the other end. The peak of where the positive charge is going to be, over here at 0 degrees, so not quite where this peak in the star is. The dip for the negative charge is going to be over here at at 180 degrees, so not quite where this point is. But then we've got more of it over here, so it's creating this slight, asymmetry in terms of the rotation there. And then, of course, we got 0 charge located at this point and at this point. So we've got the positive charge and the negative charge canceling each other, I think. Again, this would be a neat thing to get a mold of and put on top of your tree. So if you've got access to, or if you've got the ability to export these data points to a 3D printer and you want to 3D print this, send us a picture or a video of it, either in the comments below or tweet it to @Let'sCodePhysics. Let's see. I don't know why that window's open. There we go. Let's see. Let's turn this back to... Let's turn this back to uniform charge density, because we might also want to do a 6-pointed star. So we've got our 5-pointed star code here. 6-pointed star code looks very similar, except this time I got tired of copying and pasting the numbers over and over again, and I remembered, hey, I'm working in a computer program. I can save things as a value. So now we've just got angle in here. This one requires more points, of course, because it's a 6-pointed star. So this thing is going to look like this. Now it's not only symmetric about this axis, it's also symmetric about this axis. So let's run our potential integrator, see what we get for a uniformly charged 6-pointed star. Alright, we're coming up on our y=3 run. So here we've got our 6-sided star with a uniform charge distribution. Oh, let me maximize that. Cool, so very nice and symmetric. It's got all these peaks reaching up like that. Of course, you could make it negative and it would be dips dropping down. Then it would just look like that. It's a beautiful thing about positive and negative charges. You can just flip the whole thing upside down. I wonder what this would look like. I haven't tried this one yet. Let's trade out our uniform charge distribution for our quadrupole distribution. Let's take a look at what that looks like. Alright, ooh, so here is our quadrupole charged 6-sided star. So it's got, okay, yeah, so it's got a pole at each of these corners and then neutral there. That's kind of neat and symmetric in a neat way, although it's slightly asymmetric, right? Because if you zoom in on, say, right here, you've got the corner here, but then you've got the greatest dip right there. So it is slightly asymmetric in that sense, so that's pretty cool. Again, would love to get an impression of this one. I might have to hand this off to my engineering students, see if they can 3D print some of these. So thank you so much for joining me for this series. This has been a fun way to wrap things up and a fun way to usher in the holiday season. I will see you tomorrow for our Season 3 sign-off, and then we'll take a little bit of a break and be back in January. So thanks so much for watching. I will see you next time. Bye-bye.